Welcome back to Engineering Mathematics Jet Transformation Part 5. Today we will study the application of jet transformation in the solution of difference equation. Like differential equation, we have already studied to solve the initial value problem using the Laplace transformation and partial differential equation using the Fourier transformation. Both the cases in the Laplace and Fourier, we solved a type of differential equation. That differential equation is a continuous process, while difference equation is a discrete process. We have discrete domain and corresponding codomain or range. So for example, firstly let's see what is the difference equation. Then we will see how to solve a difference equation using the jet transformation. Difference equation. Let n plus 1, n plus 2 up to n plus k be the set of k plus 1 positive integers. You can see we are starting with 0, n plus 0 we can write, and up to k. So 0, 1, 2, 3 up to k, it will be k plus 1 points. In the domain, we have k plus 1 point. This is your n, this is your n plus 1, this is your n plus 2, and up to n plus k. Now, suppose we have a function y equal to fx. Then corresponding to n, we have a value of y that is called y of n. This is your fx function. Or you can write this is the value fn. Y means y is the function of x, so y equal to yx equal to fx. This is the value at n plus 1, so yn plus 1, and similarly we can see the value at yn plus k. So we have particular values of y for the particular values of x. Suppose this is your x-axis. So we have discrete cases, discrete values, some particular values of x, then corresponding values of y. And if you see yn plus 1 and yn plus k be the corresponding values of function y of x equal to fx, or you can write y equal to yx only. If you suppose this is function y equal to yx. If we use a notation, I am going to introduce a notation here. Y I plus 1, yi plus n is equal to yn plus I for I equal to 0, 1, 2 up to k. Then we can write yn plus 1 equal to yn plus 1, y5 equal to y of 5 equal to y suffix 5. Means I am going to write this value in the suffix of y. This is representing the value of y at x equal to n plus I. This is the value of x, and this is the value of y at x equal to n plus I. This notation I am going to use here. Let's see a general expression of Z transformation. A general expression of Z transformation. A difference equation of the form A naught yn plus k plus a1 yn plus k minus 1 plus so on an yn is equal to fn. See here, this is the difference equation I am writing here. A naught, a1, an are the constants. Linear, this is a linear difference equation. And how to define the order of this difference equation is called of order k. It is a linear difference equation of order k, provided it will be of order k if the coefficient of highest order is non-zero. A naught must be non-zero here. What is a naught, a1, an are? A naught, a1, an are constants. Are constants here. How to define the order? Order of difference equation. This is important. Order of difference equation is equal to the largest difference of largest and smallest argument. This value is actually called argument. So as I told you, k is this positive value, so k is 0, 1, 2, 3. So this will be the largest, this will be the smallest. If you subtract n from largest, n plus k, you will get k. So it is a difference equation of order k. Now what is role of fn here? We have two cases. If fn is 0, then this difference equation is called homogeneous difference equation. If this fn is non-zero, this difference equation is called non-homogeneous difference equation. Non-homogeneous difference equation. So this is the idea and structure of a difference equation. Now our aim to find the solution of this jet transformation. What is the solution? The solution of jet transformation is represented as yn. Yn is called the solution of this difference equation. Let's see one example and how to solve we can learn. Solve the difference equation using jet transformation. We have multiple methods to solve any difference equation. Using operator method, using generating function method, that we will study in the unit 3 also. And one of the famous difference equation is Tower of Hanoi problem. I am giving you as assignment. See the problem, Tower of Hanoi problem. See, this is a very interesting problem in the difference equation, and you try to solve that difference equation using the jet transformation. Although we will see this problem in unit 3 and we will solve that problem using the generating function method. First problem I am going to write yn plus 1 minus 5yn equal to 0, and I am giving you y at 0 equal to y0. This is the difference equation. What is the type of this difference equation? What is the order? Largest argument is n plus 1, smallest argument is n, so order is 1. It is homogeneous or non-homogeneous? It is homogeneous because the fn term is 0 here. Means no term is present except the yn term. We can call it is in other language. So take the jet transformation. Take Z transform both sides. So Z transformation of yn plus 1 and use the linear property. I told you in the lecture 1. We can separate these terms. What is the Z transformation? Use the shifting property of right and left. I told you. This will be the, and let Z transformation of yn sequence, yn is already sequence here, is y of z, capital Y of z. Then obviously the inverse Z transformation of y of z will be the yn. So if you take the Z transformation, see lecture 2 and 3, you will get this is equal to z fz minus y0. Y at 0, I am giving you y0 minus 5 y0 is given you, y0 is giving you y0 here. You can give any question, you can give any value also, but I am taking y at 0 is equal to y0. I am taking y0 only. But in other problems, I will give you some constant value like 2, 3, 4. In this problem, I am giving variable y0. Minus 5 yz equal to 0. So collect the yz term. So z minus 5 yz and take the other term in the right hand side. So it will be z y0. So yz will be z over z minus 5 into y0. Now take the inverse z transformation. Take inverse z transform. So z inverse of y of z equal to z inverse z over z minus 5 into y0. It is equal to yn only. Y0 is a constant value, so we can take outside. Now it will be z inverse of z over z minus 5. Remember, the z transformation of a to the power n, I told you this is z over z minus a. Or you can use the residue method here. The best method to find the inverse z transformation is residue method. See lecture 4 for this method. So yn will be y0 into 5 to the power n. So this is the solution of this difference equation. For many cases, y0 can be given you 2, 3, 4, 5. So no problem here. Now I'm going to solve next problem, which is closely important for the final exam. So let's see the next problem. Yn plus 2 minus 3yn plus 1 plus 2yn equal to 0. y0 is giving you minus 1. I am giving here constant value. y1 equal to 2. So see what is the classification of this difference equation? Homogeneous, because the fn term is 0. What is the order of this difference equation? This is the second order, because the largest and the smallest argument is 2, n plus 2 minus n is 2. And it is a linear. Non-linear, it is not in your syllabus. So all the difference equation in your syllabus is linear. Now, take the Z transformation both the sides. Let firstly Z transformation of yn sequence is y of z, and define inverse also here. Z inverse of yz is yn. Now, if you take the Z transformation, z of yn plus 2, we can separate every term, minus 3 z of yn plus 1 plus 2 z of yn equal to 0. Z transformation of 0 will be 0. So what is the formula for it? It is z square. You can see lecture 2, 3. Fz minus y0 minus y1 over z minus 3. The Z transformation of this is 3 into z, fz minus y0. Or you can write yz, because I am letting here the Z transformation of yn is capital YZ. So I have to take YZ plus 2y of z equal to 0. Now collect the YZ term. It will be z square minus 3z plus 2 y of z. Take put the value of y0 and y1 here and take the term in right hand side. So you will get minus z square plus 5z. You can check the calculation. So ultimately your yz is going to be minus z square plus 5z over z square minus 3z plus 2, or you can write minus z square plus 5z over z minus 1 z minus 2. Take the linear factor. Now you have two methods. You can use the partial fraction method, I have discussed already, or you can use the residue method. You have simple pole at z equal to 1 and z equal to 2. Find the residue for both poles z equal to 1 and z equal to 2 and add both the residue. You will get the inverse. So take inverse Z transform both sides. Here we have y0, yn, so we have substituted. So yn is going to be, I am going to write the directly answer, 3 into 2 to the power n minus 4. How to check the answer? This is very important. Here you can use any one of the method. Partial fraction method using lecture 2-3 or using residue method. I will prefer residue method using lecture 4. It is assignment, it is a homework for you. Try to solve and find this solution. How to check answer? Put the value n equal to 0. So you will get y0 equal to 3 minus 4 minus 1. You can see that y1 is giving you minus 1. If you put n equal to 1 in the solution, you will get y1 equal to 3 into 2 minus 4. 6 minus 4 equal to 2. You can see that y1 is 2. So our answer is correct. So in the difference equation problem, you can verify the answer also. That's very good. Actually 10 marks question, so you can verify the answer also. Let's see the next problem. Next example is y n plus 2 plus 5 yn plus 1 plus 4 yn equal to 2 to the power n. y0 equal to 1 and y1 equal to minus 4. So it is the second order, non-homogeneous, because you have fn equal to 2 to the power n. It is not 0. So it is a non-homogeneous linear difference equation. This is the classification. Take the Z transformation. Let Z of yn equals to capital YZ and defined inverse also Z of YZ equal to yn. So if you take the Z transformation both sides, take Z transform both sides, you will get Z of yn plus 2 plus 5, Z of yn plus 1, it is a sequence, always remember, this is a representation here, plus 4 Z of yn equal to Z transformation of 2 to the power n. This is important here. Sometimes people forget to write the Z transformation of right hand side and our problem is wrong. Then our problem become wrong. So it will be your Z square yz minus y0 minus y1 by z plus 5z yz minus y0 plus 4yz equal to z over z minus 2. You know the formula of Z transformation of a to the power n. Now you put the value of y0 and y1 and you will get, this is the equation z square plus 5z plus 4. I am giving some hints here only and rest you have to solve. Z over z minus 2 plus z square plus z after putting the value of y0 and yn. And yz will look like z over z minus 2. You can make the factor of it also. It will be z plus 1, z plus 4 plus z square over z square plus z over z plus 1, z plus 4. Now take inverse Z transform both sides. You have both the methods here. You can use partial fraction method or you can use the residue method. You will get yn equal to, I am directly writing answer, 19 by 18 minus 4 to the power n minus 1 by 9 minus 1 to the power n plus 1 by 18 2 to the power n. So you can use any of the method, but this is not an easy job. You have to practice a lot using a residue method or using partial fraction method. I am going to write one more problem. Next example, Z transformation. Find the solution of difference equation using Z transformation. Yn plus 2 minus 2yn plus 1 plus yn equal to n. This is an important problem. And y0 equal to 1 equal to y1. Let's see the solution. Let Z transformation of yn equal to yz. This is also second order non-homogeneous because it is n given here. And the Z inverse of yz equal to yn. If you take the Z transformation both sides, it will become zyn plus 2 minus 2 z of yn plus 1 plus z of yn equal to Z transformation of n. So it will be z square yz minus y0 minus y1 over z minus 2 yz minus 2 times z y0 plus yz equal to Z transformation of n is z over z minus 1 whole square. You can see my lecture 2 and 3. I have discussed Z transformation of n square and cube and so on. Now if you collect the yz term, it will be z square minus 2z plus 1 yz, and the right hand side will become z cube minus 3z square plus 3z over z minus 1 whole square. Now your yz will become z cube minus 3z square plus 3z. Put the value of y0 and y1, you will get this type of equation, z minus 1 to the power 4. So its inverse Z transformation is very difficult using partial fraction method. The best method is using residue method. Using residue method for finding the inverse Z transformation, you will get yn equal to 1 by 6 plus 2n minus 3n square plus n cube. This is the answer. You can verify. If you put n equal to 0, y0 will become 1. You can see here, if you put n equal to 1, you will get y1. So residue method is best method, and at z equal to 1, you have a pole of order 4. And I told you the formula for pole of order m in the lecture 4. So this is the solution of difference equation from my side, and ending of unit 2. Now I will start unit 3, that is very, very easy based on class 10 plus 2 set relation function and counting techniques. So I will start set theory from next lecture. Okay, thank you.